Hello and welcome back to the channel. Today we're going to be looking at what is known as a simple YouTube manometer with an illustration using an example. This example will show a way to find the difference in pressure between point A here and point B here, where this is a simple schematic of our YouTube manometer. Rho m is the density of our mercury in our manometer, which is this shaded portion here, with a density of 13,550 kilograms per meters cubed. And rho L is the density of the remaining fluid in our YouTube manometer, so in here and here. We're given that A has a height of 2 meters, B has a height of 1 meter, and H has a height of 0.5 meters from X, where X represents our datum, where we note that X is in line with this lower tip of the mercury. So essentially what we want to find is an expression for the difference in pressure between A and B. And to do that, we balance the pressure in the left arm and the right arm. So the pressure at X in the left arm has to equal the pressure at X in the right arm. So to do this, for our left-hand side, we have a pressure in A and a pressure in B. So in the left-hand side, we have the pressure at A plus what is known as like this rho GH expression, so density times gravity times the height. So in this left-hand arm, we have a density, well, this is all L, so density is 960 kilograms per meters cubed, times by G, which is acceleration due to gravity, 9.81 meters per second squared, times by our height, well, A, which is 2 meters. And when you're doing this, remember to use units. In this case, we'll omit them because you can see clearly everything's in meters, SI units. Well, this is in our left arm, and this we have to equate to the pressure at X in our right arm. Well, this is slightly more complex. So we'll start as we did here. We'll have the pressure at B. And now we have both the mercury, this portion, the height H portion of the mercury, and our other unknown liquid, which we have the density for, fortunately. So we're going to get PB plus, well, for this liquid, again, density 960 times by gravity, we're still on Earth, so 9.81, times by the height. But in this case, you might think that the height is the whole of B. B is 1 meter. That wouldn't be correct because our liquid only starts from here. So this remaining height here would be B minus H, which is 1 minus 0.5, which is 0.5 meters. And now we must add on the final contribution, which comes from this mercury, which again, rho GH, density of mercury is 13,550, times by 9.81, times by, well, this one's rather more simple, H, which is 0.5. So now we have one equation with our two unknowns, but we are looking for an expression for PA minus PB. So we can simply rearrange this now, and we will get that PA minus PB is equal to, well, because we want to get the PB over to this side, we'll work out this, and then obviously to change the subject, all we need to do is subtract this term off. So PA minus PB will be equal to 960 times by 9.81 times by 0.5, this, plus 13,550 times by 9.81 times by 0.5, this. And remember, we're changing the subject, so we subtract PB from both sides, so we need to also subtract this, so we'll get minus 960 times by 9.81 times by 2. Therefore, our final answer is that PA minus PB is equal to 52,336 Pascal, which of course, for want of a better way of leaving this due to its magnitude, is 52.3 kilopascals. And as you can see now, just using this simple example of a YouTube manometer, in reality, we may know one of these two. So in this case, if we were then given as a follow-up, given that PB is 30 kilopascals, what is PA? Well then, you know PA minus PB, you know one of them, so you can get the other. So you can see a rather simple extension to this question in that sense. But yes, so to summarize, this video was a very short introduction into how to deal with statics with a specific focus on YouTube manometers. I hope you enjoyed, and I'll see you in the next video.